All right, hi everybody. This is Barclay Brown. I'm CIO of INCOSE, and here your host for the INCOSE Connect. And today with me is Michael Watson from a team that created a very interesting INCOSE work product. So we're going to hear about that today. It's called the SE Principles. So Mike, welcome to INCOSE Circuit.
Oh, well, thank you, Barclay.
So first, tell us just a quick sketch of your background as a systems engineer. Where did you come from? And I think you've even made a recent career transition also.
Yeah, I spent 33 years with NASA and just recently retired. With NASA, I was a systems engineer my entire career, working space station, Ares 1, specifically abort systems, helping get the SLS program established. Then the last 10 years leading a systems engineering research consortium looking at the engineering foundations and the mathematical foundations of systems engineering. Recently transitioned and retired from NASA, and am now working for a company called Dynetics. And the one consistent theme in everything that I've always done has been systems engineering, right? It's systems engineering is consistent across company boundaries when you look at it.
Mm-hmm. Now, some would say that that's not much of a retirement. You leave a job and then you just go to another job. But
right.
you do what you like to do, right, in life. That's the idea.
But I said I'm not really ready to retire. I'm just changing jobs. So
I did the same thing. Yeah.
Yeah.
NASA has always been big in systems engineering. I remember teaching systems engineering years ago, and we used the NASA systems engineering handbook. That was this big, big
right.
thing. And NASA had formalized a bunch of systems engineering stuff that was very valuable and kind of made it available to everybody. So that was great. Right. But let's talk about this new work product called SE Principles. This is something that you've led the team. You're the team lead for creating this work product. It's a book, really. I guess we could call it a book.
Right.
How did that idea get going? What was the beginning of the idea for that book?
Well, as I said, we were doing the Systems Engineering Research Consortium, and was working a little bit on that with former NASA Administrator Michael Griffin, and talking about, okay, what's the underlying basis for systems engineering. And he said, what I'm really looking for is what Ludwig von Boltzmann did in researching gas dynamics, right, which is another form of a complex system. Mm-hmm. And he postulated. And so Mike kind of challenged us to postulate what might be the basis of systems engineering. So in the consortium, which was a large group of universities, NASA, Air Force Research Labs, we did that, right? We said, well, what would be the postulates of systems engineering? We wrote down, we ended up with 7, and then we expanded those into a set of principles. And while we had 17 universities, we realized, that's a really small set, really small view of the overall systems engineering community. So I talked with David Long, and David said, hey, why don't you form an action team and let's let INCOSE kind of look at that, right? And so we formed an action team and took that set of postulates and principles, and there are a couple of hypotheses we felt needed proofs, and kind of went through that as a team and looked at all the information, how we might format it, what it says, what changes we might want to make, what other viewpoints are coming in that we didn't have in the consortium. And that led to what we decided to call a set of systems engineering principles. So we vetted that through some international symposium presentations. We peer reviewed it with AIAA and IEEE and NDIA systems engineering communities, and that led to the recent publication of the systems engineering principles by INCOSE.
Terrific. Well, the first thing I thought of course, maybe as a lot of people do, is Ray Dalio's book about 5 years ago called Principles, right, which was a huge hit of a book. And I think it kind of established this notion of a principle, like what is a principle, right? And it's, as you differentiated it, it's not a fact. It's not something that you could prove or disprove. It's not a falsifiable claim. It's a element. It's a piece of guidance, right? It says you should, right? You should something, right?
Right.
Like, buy low, sell high. That's a principle. You can't prove that. It's just like, this is how you should operate, right?
Right.
And unless people agree that that's how you should operate, then that becomes kind of a principle,
Right. Right. And David Rousseau was really helpful to our team in sorting through the terminology and what's a principle, what's a postulate, what's a hypothesis.
Right.
And he served on an activity between systems engineering hypothesis and systems engineering principles that we called the bridge team, and came up with the notion of guidance propositions, which I thought was an excellent description. As you just said, it's guidance of the principles and the hypothesis, and they're kind of a transitional path between the two, and all encompassed by the idea of guidance propositions.
Yep.
So that's certainly a good description.
It makes a lot of sense, because systems engineering, as you know, right, is mostly about that sort of thing. It's much less about provable maxims, as like you would find in an electrical engineering or a mechanical engineering or something, which are driven by mathematics and equations and things that you can prove or disprove. Systems engineering is different. It's more of an approach. And in INCOSE, in fact, we say we kind of sum it all up and we call it systems approaches. Meaning systems engineering, systems thinking, systems science, all those are systems approaches somehow, right?
Well, that's interesting about the principles.
Yeah.
Because there is a principle on the basis, right? And it says that systems engineering has a general systems theory basis. It has a engineering physics basis, and it has a mathematical basis, and it has a sociological basis, right? And so we think we've opened the door to start to look at some of the mathematics that perhaps underlie what we do in systems engineering, to kind of to cross that boundary or to address that gap that we currently have.
Well, that would be interesting. That'll take one or more additional books to spell out, I'm sure, right? When that happens, right? So back to principles. And by the way, this book is available on the INCOSE website. Anybody can just go to incose.org/SE principles. So incose.org/SE principles, pretty easily. Principles with a PLES, right? Remember your spelling. Right. So there you go. And you can, as a member or even a non-member right now, you can download it at no charge. It has a cover price, but right now we're making it available at no charge. So for people that want to go and get it, you actually buy it through the INCOSE store, even though there's no price. That's just the mechanical part. So Mike, can you give us an example? What's one of your favorite principles that you'd show us here from the book?
Yeah, I can. The one that probably the most significant is actually the first conversation that I had with Michael Griffin, was something that he stated, and we both said, that's a principle, right? Is systems engineering and application is specific to stakeholder needs, solution space, resulting system solutions and context throughout the system lifecycle. It's really important to recognize, as you're doing systems engineering, that what you're doing is specific to the system that you're ultimately trying to produce, right? And it will vary how you apply processes. The organizational constructs can be different, and that will lead to variations in processes. And we see a lot of that in practice. And that principle really kind of embodies that of, pay attention to these things and be specific about what you're trying to do.
It also mentions stakeholders, and so it indicates that the system you're working on is really, it might be the same system, but if it's for different stakeholders, that makes a whole different thing, right? Because they're going to have different needs and expectations and wants and desires and requirements and all of that. And the systems engineering is specific to meeting those. There's a part of systems engineering called quality management, right, that deals specifically with that. Is like, are we meeting a particular stakeholder's needs and wants, and even their expectations, right? Because people have expectations that may or may not be written right in the requirements. And systems engineering is part of getting something that will work for the user, not just meets the requirements and we can sign off and say we're done, but actually succeeds for the user's use.
And a good example of that's in the aircraft industry, right? Look at the Boeing 707, right? The first really commercial jet airliner that was very reliable, very successful, The Air Force turned it into a tanker. Very different stakeholders, very different configurations of that same aircraft. Same engineering teams working on it, but producing very different configurations because the needs of the stakeholders were, very different. So yeah, absolutely.
All right. Well, terrific. So where do you go from here? Do you have like a follow-on planned, or are there certain activities you're planning on doing with this book? Or are you like, okay, wrote it, put it out, done, and now you're going off fishing or something? Yeah.
So one of the things, and we say it in the preface, is this is the initial set of principles, right? It's to start the discussion. This is not okay, done that, move on. This is now the discussion has begun. And we've created a feedback link for people to provide feedback if they've got thoughts of, hey, what about this? Is this a principle? Could this be an addition? Comment on what we have out there. Start the conversation with the systems engineering community at large. Have academic institutions across the globe looking and being informed in research in what they're doing, and try to kind of build on the foundations of systems engineering. Get a clearer picture of what that may be. So,
oh, terrific! So it's the beginning of a conversation, like you said. So that maybe there will be other forms of it and other discussions and other versions of the books, or who knows what, right? Coming out of that whole dialogue.
Right. It's sort of like the principles we're working now on version 5. I'm sorry. It's sort of like the processes we're working now on version 5. And we've had the processes, about 20 years or so. I expect the same kind of evolution of the principles, right? As we discover new things, realize new evidence, research uncovers things that become part of that principle space.
So it'll evolve, just like that. Just like the systems engineering handbook has evolved. As you said, we're about to come out with version 5, and what does version 5 mean? Does that mean we got it wrong in version 1, 2, 3, 4? No, it's just things evolve, right? Things change and things grow and so forth.
Our understanding matures, right? Gets broader, right? So
we discover new things. It's all progress.
Yeah.
All right. Well, I think we'll leave it there. So Mike Watson, team lead for the SE Principles book, just released by INCOSE. You can find that at www.incose.org/SE Principles. And you can get it there at no charge at the moment. And Mike, thanks for being with us on the INCOSE circuit, and we'll see you next time.
Thank you, Barkley.